Welcome to Python for Introductory Statistics. In this video, you will learn how to use Python to do some frequency distributions with qualitative or categorical data. Let's look at this example here. Here it says 20 students were asked if they were registered to vote. The responses are listed below. So the first person said, no, I'm not registered. The next, no, yes, and so on. And then we're asked to write a program to construct a frequency distribution for this data. So it would be easier to copy and paste. That way you don't have to spend a lot of time typing each of these one at a time. So let's go ahead, open our Google Colab notebook. You've learned how to open this, or you can just search on Google for Colab, C-O-L-I-B, and this is usually the first on the list of searches. So I'm going to go ahead and start by, let's say, import NumPy. We're going to need the NumPy library to do a lot of statistics, so you get used to it. Then we will list all the values. So remember, the first one was no, because these are qualitative or categorical data. We'll put it in single or double quote, no. And then the second one was another no, and so on. So to save time, I've saved it here, and I'm going to copy and paste it here. So when values are not quantitative, as in integers or decimal numbers, we had to put them in single quotes or double quotes, and that's how Python will read this not as a number but as a character or as a categorical data. All right. Now we have our data. The next thing we'll do is we will call the function, the NumPy function, and it's called unique. All right, unique. So we have to remember these terms. It's called unique np dot unique, and we're going to tell that the variable is in x. And if we just run this program as it is, it will only list the unique values, which in this case they're only no and yes. There's no other option. But if you wanted to know the counts, then we have to add a comma and then return counts as true. Right? So now it will return not only the unique values, but it will also return the counts for each. So if we go ahead and execute or run this code, uh, Python will tell us that the unique codes are no and yes, so it gives it as an array. And here it says this data type is called, this basically means we're dealing with characters or categorical data with 3 letters, right? We can ignore this. And then the second array is the counts. We said that we wanted the counts, so there's 9 and 11. So in this case, the no's were 9, right? And the yeses were 11. I think this is clear, but what we could do is we could add some other more functions of NumPy to make this more clear. So let's say in a table form. So let's say table is equal to a zip is a function that will take each of the values and the counts. So we're going to zip these two values, and we call them value and frequency. And now what we'll do is we will ask NumPy to give the output as values and frequencies. So VAL is for the unique values, right? And we can put this as a tuple in parentheses. So the output now, instead of listed as an array here, it will take them as value and frequency. This is our choice of letters. It doesn't matter what you call it. And then we will list this so it will be in a slightly better output. You don't need to do what I just did if the previous was clear. In this case, now what it listed was no is 9, yes is 11. So now we have our frequencies. There are 9 no's and 11 yeses.